Let's write down some words. There is a relationship between, where's this little writing thing? All of this thing, these four components, it's going to be your task to be able to produce kind of all of them based on a relationship. Write down relationship. Now, in real life, relationship, of course, we know it deals with people. It's how they connect to each other. Relationships. So if relationship is up there, you can put, connection, or if it's not one of the words, it's not. But a relationship is a connection. Now, they're going to be doing relationships between numbers, and the relationship between numbers. Sometimes we use the word map. One number will map to another. Again, remember, it's kind of a vocabulary class that I'm going with. But the word that they ultimately will land on as they talk about a relationship between two numbers will be, this is the one they're going to use over and over again. Function. Function is a famous word. Oh, if there's only one word I could have you know, whoever is in charge of function, this is your turn. It would be like, what is a function? Every time they say it's supposed to mean something. So let's see if I can get a relationship that is a function and one that is not. Can I write over here? I don't know how much space they have. I don't want to use it up and mess it up. So I'm going to go with, let's see. 3 to 4 people who are willing to say their age, their first initial, and then their age. 3 or 4 people who are willing to say it. I'm going to get that. I'm going to show you a relationship. I want to say relation, but I'll say relationship between their initial and their age, and then I'm going to talk about this thing called a function. So you'll always hopefully feel it. Here it comes. Let's see. I need 4. 1, 2, 3, 4. One person at each table who's willing to. Like somebody may not. I don't want to say my initial, and I don't want to say my age, that's fine. Someone at this table, please say your first initial and your age if you're willing. And choose the table who will do it, whatever. Go ahead.
R, 17.
17? All right. Back table?
A16.
A16. Back table?
M16.
M16. It's near my graph thing, which I don't want to. I might still erase it. I just want to convey this function thing. Maybe I can put it in there. And front table. J17. Oh, yeah. I'm glad that's there. All right. So here is a relation. When I say R, I know 17 is the correct age. Age 16. This is a relationship. I want to say relation. I'm going to say relation or relationship, and eventually I'm going to go back and say that one word was right and the other was wrong. This thing here, at some point, someone is going to say, this is a function. The question is, okay, what do they mean? So that when we use it with math, like, well, what do you mean it's a function? A function is a relationship where for each one of these letters, they only have one age connected to it. In other words, R, whenever I say R, he's always 17. Whenever I say A, she's always 16. If I say M, you would say, well, how old is M? 16. The relationship says so. Oh, that's how that'd be. The double numbers are just by chance. How about J? How old is J? This is a function because for each one of these, they only have one number that's associated with it. Let me break it and change it to make it not a function. Because eventually you will be asked, the relation that you're given, is it a function or not a function? Sometimes they'll give you the picture version of a graph. Please look at this graph. Is this graph a function or not a function? What are you asking me? This is a function. Let me change it and make it not a function. R said he was 17. He goes to his next class. They ask him how old he is in his next class because R kind of wants to be cool. What he will do over there is he'll give his initial, but instead he will say that he's 18. Maybe he's gone to a club. Club, do you need to be 18 again, or is it 21?
It depends.
It depends, okay. It depends, all right. Oh, drinking. Drinking would be 18 or 21?
21.
21. Now, they can't see you on here. They can't see you on here. So he goes somewhere, he says he's 18. This is no longer a function. What do you mean it's not a function? To be a function, whenever I say your letter, whatever the first thing is, which officially they're going to call it an input. The output, the thing that comes out of it, the input and output, somebody has input, someone has output. It's not, oh, there's input. Output has to be somewhere. It has to say the same thing every single time. Basically, to be a function, you are not a liar. To not be a function, you are a liar. In other words, sometimes you say, yeah, I'm 17. Hey, how old are you? I'm 18. Wait. Are you 17 or are you 18? You only get to be one. And so when we talk about a function, that's all they mean. All they mean is, for whatever input there is, it maps to only one output. So if A was 16 here, when she goes to the next class, she has to be 16, otherwise it's not a function. And so this is a bad thing here. You can mark it off. So when they talk to you about a function, all you're meant to be saying, so I got two rows of things where one has to go just to the other. And so that's fine. That is a function, at least the first time you'll hear it over and over. So let's create a situation, which is what they want to know, a situation that will produce eventually a function that hopefully you'll be able to create an equation for it. The table. We couldn't make a table for this thing by just... Yeah. This is the most famous table. They're going to want you to be able to produce a table from a situation. So let's see if I can do the situation, see how close you get to creating a table for it, and then we'll go from there. So there it goes. I have a little sister. She is 3 years younger than I am. Okay, she's 3 years younger than I am. So let's try this. So down here the situation, right down here, sister, 3 years younger. Part of the test on the fours, they will want you to be able to describe what the function is talking about. Now sometimes they'll just give you the story, so they give you the situation. Yeah, that's cool. They're like, hey, can you give me an equation? I'm like, what? He has a sister, he's 3 years younger. Like, what? What's the equation you want? But I'm still guiding you through it. Let me ask you this question. If I am, I'm going for a table here, and hopefully you can feel how you build these things. My sister's 3 years younger. If I am, let me make myself 10, how old is my sister? Just write it down, just write it down, And you, hopefully, even as he's speaking and some of you are thinking it, hopefully it doesn't feel like a big deal. But this is actually what they want you to know. They want you to feel math as opposed to like, all right, give them 10 problems. They want you to feel it. If I am, let's say if I'm 7, how old is my little sister? If I am, let's make me 40. How old is my little sister? For those of you who are not good at math, hopefully you are feeling like, yeah, this is easy. And not only is it easy, but it actually is important. You're going to need to produce one of these, and it's just that easy if you know the situation. Here comes a trick question. How old is my, I really do have a little sister. How old is my little sister right now? All right, so the dependent variable is the answer to the equation. Usually it's the y. So independent variable, you can put, for dependent variable, you can put the letter y in that box. You can put output in that box. These are all the things that relate to when you hear the word dependent variable. What is something you're supposed to be thinking? You may not know the answer, but oh shoot, it's probably the y, it's the output, and it is the D, this is important, dependent variable. Hey, somebody say out loud what a variable is. Something that could be anything. In math, what do we normally use for a variable?
X.
Yeah, X, a letter. What's true is it can be any letter. I remember either teaching it or hearing it. A student would ask, what is X? And then the teacher would say that crazy thing, it's anything. And then you would say, okay, X is 7. They're like, no, you're wrong. Well, I thought you said it could be anything. But X, as a variable, is not a thing, it's a door. It's hiding the answer. So when you talk about a variable, yeah, last one. Start drinking water. So from there, it's a variable, it covers it up. So let's see what we got so far. I'll ask it, if y, my sister's age, is the dependent variable because it depends on my age, what would be the independent variable? Yeah. X or the input. My age, I tell you that, I give you that. Like, my age doesn't depend on anything. My age is my age. It's my sister's age, the answer. So over here, you can put in. Anybody who likes vocabulary know what in is? A prefix. It comes with 4 things. Anybody know what in does to whatever comes after it? It's a prefix on a word. You put in on the front of it, it does something. Sweet, I get to say it. I like vocabulary. I bought a $200 vocabulary program called Verbal Advantage. That way I have the verbal advantage. I'm like, boom! They say the more words you know, the more money you will make in my video. They studied it. The Johnson O'Connor organization. In is called a primitive prefix. This one I'll pause. We'll write just because I like it. All of these, all of these are primitive prefixes. They undo the thing that comes after them. And the only reason they have so many of them is that it was hard to link it. So independent sounds good, but irresponsible as in irresponsible. Irresponsible felt weird, so they're like, oh, let's change it to irresponsible. Now, impossible is close enough, but they're like, nah, let's make impossible. So they just switched them so it could sound good. In any case, let's see what we got so far. We got say it again, independent, say it again.
Swindled out of your money.
Swindled out of my money.
Yes.
Yeah, that's because you're in high school. All right, so here's the deal. Independent is the thing we're putting in. The last thing, ooh, I'm going to do this one, I want to do this one. I thought about it last night. With the whole input-output thing and function, my last picture, so we can continue finishing it, my picture, so that you will never forget function. This is my gift to you. You're going to grow up as an adult, and you should remember the example I'm going to give right now. You are a function to your food. You are a function. As a machine, you are a function. Your input is the food that you eat. The output usually is brown. It's usually brown. Now, if the input is corn, yellow corn, you should know. And you can check it next time you're in the bathroom. You can check it. I'm moving forward with this thing. I've already committed to it. If you eat corn, you can check this tonight. Anybody have corn at home? Corn at home? Yeah, I'm recording this. You check it. You eat that corn, and then the output, the Y value, is going to come out in the bathroom. Now, yes, normally it is brown. But you check it. It will be brown with yellow polka dots. Yeah, no, it's true. It's true, you check it. You are a function. The input is the food you eat. The output is brown. It's poop. I know. I want that. So when someone missed class and they're like doing it, they listen to it. A function is all about input and output. Yeah. You will never forget that. Brown with yellow polka dots. I am 45 now. Please write down. Yeah. Please write down how old my sister is. Because it's a function. All right, so here, let's do this. Let's get an equation. This one I'm going to challenge you to see what you produce with the equation. Let's see what they produce with the equation. Let's go with, do I want to help them? I'm going to say it, and I'm going to let some of you fight with it. I want to give you a hint. That way, if you get it, you feel like, yeah, I got that all on my own without help. So here's the deal. My sister is 3 years younger than me. How can they write that as an equation? Like, if ever you want to find out my sister's age, don't say it, because I want people to try and write it. So you're going to try and write something down, and I'm going to try and write it. My only hint will be, in the equation, you're going to put the letter Y and X somewhere. Another hint is my sister's 3 years younger than me. Don't say anything aloud. How might you write that as an equation? For those who aren't good with equations, there must be an equal sign in there somewhere. Let's pause. That my sister is 42 right now. You figured that out somehow in your head. You're like, bang. When I was 10, you figured out that she was 7 somehow. So in your head, somehow there's an equation that you can write for that. So let's see. Wrote Some people wrote x minus 3 equals y, and some other people wrote y equals the x minus 3. Somebody's right, somebody's wrong. The question is, which one is right and which one is wrong?
They're both right.
He says they're both right. I'm saying someone's right and someone's wrong.
The top one's right.
Right? Bottom one's
That one's
wrong.
wrong.
Everyone's right.
Say it again.
Well, I mean, no.
Everyone's right.
Which one's right?
You got the answer.
Bottom?
Yeah. Same thing. It's the same outcome.
No.
And someone just didn't even use that at all. They just put f of x equals x minus 3.
Which is why.
Yeah. So here's the deal.
Yeah.
Of course, I tried to start off by saying someone's right, someone's wrong, so that someone will believe it and start going like, but it turns out they're both right. An equal sign just says that everything on this side is equal to everything on that side. So the order technically doesn't matter. Of course, the way that they will offer it to you most of the time is with the y first. My sister's age equals whatever my age is minus 3. This notation here is called a function notation. The F is just a way to name the thing. Like, oh my God, the F is like the car that you will drive. Let's pause for a second. Let's see if anyone knows. Investigate. If you're given a relationship, can you get a table? Can you describe the situation? Can you produce an equation? And can you make a graph? So for this class, investigate is investigate a relationship. Just like in real life, we investigate things. There's a car turning on the freeway. We slow down. I gotta go. Or if more recently, as I've been seeing people around, I've been investigating. Like, why are people looking the way they do? Some people aren't exercising as much. So here's the deal. I've been investigating. So investigate. You can put something that I wrote down here. We'll erase you. You don't have to. I didn't want you to write it there, even though I wrote it there. I feel bad about it. I shouldn't have done it there. We can describe the situation. I'm going to erase this g of x thing. And I'm going to even erase his f of x, because at this stage, initially they're probably going to start with just y equals. You don't have to erase it, unless you want to. And then, again, someone say out loud, if I'm 7, how old is my sister? And if I'm 40, how old is my sister? All right. So if anyone's not good in math here, I hope today is a good day for you, because as easy as some of this may feel, it actually is like way important. And I'm glad that they're doing the easy version of something that's so important, like a function. A function is just a relationship between two things. And those two things, they're the only two connected to it. Whenever you say, Thomas, who's your wife? It's Marcia. If ever come back, hey, Thomas, who's your wife? It's Raquel. There's a problem, because they're both there. And that's illegal. You can get arrested. I think except in Utah or something. I think somewhere you can do it, but I think it's illegal in general. All right, here we go. Let's graph this thing. To graph, you are just going to put dots on an xy plane. Now, this is going to be an ugly graph because I have to scale it. What do you mean you have to scale it? I need to make the x line include numbers as small as 7, but as big as 45. Does that mean I'm going to do, let's see if I can do this thing. I didn't think about this while I was getting ready to do it. So I'm going to have to, I don't want to do that because it looks like it's that thing. So let me make it a blue. The x-axis, the side-by-side is always the independent variable. Whenever you have to make a graph, once you figure out who's the independent, what's the thing that changes the other part, he will always go left and right. The dependent variable, ooh, I can start using the words now. The independent variable will always be called a domain. I have 1, 2, 3, 4 domains. Ooh, yeah, you put in the domain. Come on, domain. Domain. You put in the domain. You eat the corn, you eat the watermelon, you eat the burrito, you eat the taco, you eat the curry chicken if you go to the spice jar, and then you get the range. Can I say the range comes out your butt? Can I say that as a teacher, or I'm not really Can I say that? Am I recording? Yeah, that's bad. Okay, yeah, that's cool, whatever. Maybe I could have posed you the question, what is the domain? What is the range? The domain always has to do with the x. Close enough. Domain has to do with the x. The range has to do with the y. Now, I'm not saying they do not find it. I just want you to feel like whenever you hear, hey, anybody know the domain? You mean like the x's in the problem? Yeah. So I'll try it this way. One person at each table, I'm going to ask you for one of the domains. A different person at the table, I'm going to ask you for one of the ranges. Now, I'm using those words a little bit wrong because the domain are all of the possible x's. Not just each individual, but I'm going to do it individually. Back table, I'm going to ask you for one person. One domain, one domain, one domain, one domain. You ready for it? Let's pause it. Sure, let's do that. All right, one domain, back row.
7.
7 is one domain. What's one domain? 10, yeah. Another domain? 40. And the last domain?
45.
We're doing ranges. Right, wrap around. One range, please.
7.
But a different person. Were you the same person? All right, different person, different person. All right, still, no, it's too late. All right, second range.
7.
7, nice. But we're going to do a different one. I'll take that 7. 40, did you do that last time?
Yes.
The only once, man, the only once.
37.
37, okay. The domain, the range. I want the words to be like easy for you. When I say find the range, you mean one of the y's? I will say no. Actually, you have to give me all of the y's for it to really actually be the range. If I say, give me one of the domains, which is, you don't even say it that way, and you said 40, I would say, well, no. The domain is actually all of the x's, all of the input, all of the corn. It's all of it. All right, let's draw this picture. Draw this picture. I'm going to scale it where each one of my tick marks, 1, 2, 3, 4, I need to go a little further, 5. Normally, each one of my tick marks would be 1, 2, 3, 4. But for scaling purposes, it needs to be, I'm going to make mine 10, 20, 30, 40, I'll even do 50. Now let me ask, normally we put numbers on the left side. Can anyone guess why I'm not going to put any tick marks to the left of the origin? Anybody know? Yeah, there are no negatives. My domain doesn't include negatives, and here's the beauty. To get a 4, they're going to give you a situation, and they're going to ask you, are there any restrictions on your domain? Which is math talk for, are there any x's you can't put in there? Like, for example, when I'm, for those who know positive and negatives, when I'm 2, how old is my little sister?
-1.
Right, but can anyone be a -1 years old? Yeah, so eventually they want you not just to get the answer. Yeah, they don't want you just to get the answer, which -1 is the correct answer. But because it doesn't make any sense, I'm like, no. If your students don't know that it doesn't make any sense, sorry, bad news. All right, see, let's do this picture. We got our domain. Let's put in our range. How big did they get? 7 to 42. Sweet, sweet. We can use the same scale for the top, but guess what? If ever you wanted to, you could change the scale on the red line. In other words, you can make each one to be 5, 10, 15, 20. But for our purposes, it still makes sense to do 10, 20, 30, 40. So go ahead and scale it, and then from there, for those who know how to put in the dots, in other words, at 10 on the x, I'm going to go up to 7 on the y and put a dot. That's all you're doing. It still goes back to 6th or 7th grade. I think they were doing this in 6th or 7th grade. Why they're redoing it? 1, 2, 3, 4, 5, 6. I need this got to be 10, 20, 30, 40, 50. Booyah, she knew it was coming. All right, graph just means put a dot. This is a graph. If you've ever wondered, I mean, for a while, I mean, even as a math student,
Right, please. You can't just put a dot anywhere.
Right, you can't just put the graph anywhere, but no matter where you put it, it is called a graph. No, we're going to put it in the right place, but I just want you to feel when a teacher at math teacher says, we're going to graph the equation today, I want you to feel, oh, we're going to put dots somewhere today. Because any high school student can put a dot somewhere, but I've heard high school students say, I'm not good at graphing. Which just means I'm not good at putting dots. somewhere. And I want you to feel like you can be good at putting dots somewhere. All right, let's put in these dots somewhere and then complete this section, turn in there.
I don't think it's the putting the dots somewhere. I think it's putting it correctly and doing it correctly.
All right, well, let's do it. Let's do it correctly. Then here we go. The first one, X, the input, the domain is a 10. The range is a 7. That's about right there. 10, 7. 7 is below the 10. You know, I have to be exact. The second one, I'm going to do the second one, then I'm going to try and get you to do the last two. Some of you have already done it. You're experts at this, which is why you're going to get a free credit for Unit 1. Some people, this is like easy. This is it. Yeah, this is it. If you can do these 4 things, then boom, you get free credit at the end of this month. Here comes, I'll do the second one, then you do the third and the fourth. 7 and 4. Oh, maybe I should have scaled it differently. If it goes 7, not quite 10, and then go up 4, not quite. All right, that's the best I can do on that one. Once you have put in your other 2, what does he want me to make up? You got to make up 2 scenarios where this equation is going to help you get the future answers. Try it if you get super stuck. This one I'm willing to let you out here. Let's see. All right, David, what you got?
The number of cigarettes C smoked is 5 times more than J.
Okay, all right, there it is. There it is. Smoking cigarettes. Whatever you guys smoke, 5 times how much you're smoking, so you can perhaps die earlier. All right, here we go. Table 2. What do we got here? Who chose? What do we got?
3 people buy a car every day.
3 people buy a car every day. So if it's today, 3 people? All right, so okay, today, multiply that times 3, boom. Okay, I know how many people bought cars today. What you got here at this table?
For every amount of XP a video game player uses, they lose 3 XP every time.
All right, all right. Oh, yeah, that is true, that is true. And we might adjust that. The cigarettes, there were 5. I'm going to say something about that. I just realized. Back table, one more situation.
Okay, the distance between the sun and the earth is 10 times that of the moon because science.
All right, this is 10 times. I got it, yeah. So here, let me say this. And I didn't realize it when I heard the first one. Those situations all are good situations. The situations, based on what I want to do now, I just realized that it needed to be able to produce this equation, though. In other words, so I wasn't clear on that. And so anybody who had, let's say, a 5, a 10, or a different number, it wouldn't go with this one, though we could come up with an equation for that situation. And even the one that had a 3 cars per day, well, that situation would have been multiplying 3 once we finally produce an equation. So if we did it again, which we're not right now, we're about to peek at one more problem where we do these things. The problem on the board, you can tell there's going to be a picture. You can tell there's going to be a table. Booyah, thank you for the equation already. What page number is this one? Someone find it so I can say, oh, this is 5, page number 5. The only thing we may not be able to do with this is come up with a situation. I'll come up with a situation. So here's what I want you to do. To use our calculators, we're going to use the calculators to fill in part of the table. We'll use part of the table to be able to do part of the graph. And then I'll help you choose this answer. All right, so what do I want them to do? Take calculators, turn them on. This is a thing you're supposed to hit. Blue, plus sign, 722. All right, everybody hit blue button. When you turn on your calculators, hit blue button. We're at the end. Plus sign. It's on the right, plus sign. Hit the number 7, 2, 2. That resets the calculator. Blue button, plus sign, 722. Blue button, plus sign, 722. Blue button, plus sign, 722. All right. It resets everything. Sometimes they change it to radian mode, degree mode. Here we go. Do me a favor. At the top left corner, there's a gray button. It says y equals. Everyone hit that y equals. And that y equals looking on. Somehow one of ours is missing. Y equals is where, if ever they said, hey, Thomas, I want you to produce a table for this problem. Now, there's a long way that I will make you do, where you have to put in a 1 for the x, 1 wherever you see an x, work it out, it'll give you an answer. But in this case, I'm going to have you use your calculators to get the answer. So here's what I want you to do. Y equals. On that line, I need you to hit the letter X. Where's the letter X?
Right there would be fine.
The letter X is here next to the green button. Green button. To the right of it, you see X, T, theta. If ever you need a variable, a letter, you'd hit that button. So hit the letter X. Right next to the green button. Look on somebody next to you. This is always the hard part. To raise it to the second power, you will see 3 buttons below green. 3 buttons below green. You can see an X squared. Hit X squared, please. 3 buttons below green. I hit X squared. You will see now it's X squared on your calculator. If it's not, look on someone else's. So next thing we're going to do, hit minus, regular old minus. To get a 2, we're going to hit a 2. Hit a 2. To get an X, again, hey, where am I going to find the X? Find the green button and the button to the right of the green button. You hit that, you should get an X.
Wait, where? I took the chart of that.
The Y equals, gray button up top says Y equals, the gray button and Y equals. And then the last thing, hit minus 3. So on this one, we're only going to be able to fill in part of this table and 2 dots on here. Fill in table, 2 dots, and that'll be it. Hey, Thomas, how am I going to fill in this table with what I just put in? I'm going to go over to, there's a button over here, all the way to the right. You'll see a blue word, table. Top row, all the way to the right, blue button, table. What you will do is you will hit blue button here, and then table. Blue button, and then table. Blue button, table.
That is the table.
Oh,
All the way to the right, it's in blue under graph. Once you get that, it automatically gives you some partners that you can put in. Hey, Thomas, which partners do I choose? You always want one of them to be X is 0. Like that middle guy where it's 0, comma, negative 3, you always want 0, negative 3. And in this case, I'm going to have you do, how many do we have? 1, 2, 3, 4. We're going to do 5. We're going to do 5. 0 is going to be in the middle, and then you'll do positive 1 and 2, and then negative 1 and negative 2. What does he mean? What does he mean saying? He wants, oh, don't erase that. He wants, let's see, negative 2, negative 1. He wants 0. He wants 1. Look what I have on the board. Look what I have on the board. Now, I put it in the wrong order. Maybe I should have put the positives on top, the negatives on the bottom. It doesn't matter where a Rohan is. He's going to be 17 no matter where he is. In other words, it doesn't matter where you put the independence. What's the partners to negative 2? You put in the partners. Negative 2 is a 5. Anybody know what the partner is to negative 1?
0.
The partner to 0? The partner to 1? The partner to 2? He either is a genius or he knows where to look on his calculator. Okay? All right, last part. So here's what we have. You're only going to get 3 pieces of this puzzle. We have the equation. Abbreviation equation is EQN. We have a table. This is what they're going to ask you for on your test, and there might be a point where you get to use your calculators. But you got to get those 4 things all the time. Graphic, Thomas, what's the numbers? They're small numbers. But because they're small numbers, my, what's that word I'm looking for? My scale is just regular. 1, 2, 3, 4, 5. Up here, 1, 2, 3, 4, 5. 1, negative 1, negative 2, negative 3, negative 4, negative 5. Really, I guess you don't even need to write the numbers, but I will. Negative 1, negative 2, negative 3, negative 4. I am squeezing in this last part, so at least I can get 3 of the 4 pieces. What's the situation? I don't know the situation. Well, I do know the situation, but... All right, hey, Thomas, just put in some dots. Guess what? On a test, chances are 3 out of 4 gets you a 3, you pass. So some of you might be like, okay, and again, we'll review it next time. I'm going to put in some of the dots. I know it's calculated, should have spent more time. Here we go. Negative 2 and a 5. Negative 2, go up 5. Negative 1, I'm at 0. 0, I'm at negative 3. 1, I'm at negative 4. That's an ugly picture. 2, I'm at negative 3. 2, I'm at negative 3. here, and then that'll be it. Technically, if I was connecting the dots on this, these dots make the letter U. That letter U is the official color parabola. We say it's quadratic. Anything that has x to the second power is quadratic. You can just write this part down. We're going to say it over and over this unit. Anything else I need to know? What's the situation? You're on a swing. You're swinging down. You skateboard. You're in a half pipe. Those are situations that this picture looks like. All right.